Hello everyone. In previous lectures, we have studied the unilateral Z transform and its inversion. In this lecture, we will discuss bilateral Z transform and its inversion. It includes definition of bilateral Z transform, properties of bilateral Z transform, and the inversion of bilateral Z transform. First, we'll give the definition for bilateral Z transform. This is the definition. The range of R for which the Z transform converges is termed region of convergence. The inversion of bilateral Z transform is defined in this expression. It's similar with the definition of unilateral Z transform. Here we will discuss the bilateral Z transform for some signals. First, the finite length signals. For example, determine the bilateral Z transform for this finite length signal and its ROC. According to the definition, we can get this result. Here, ROC includes the entire Z plane except Z equals 0, because the signal is a finite length signal. We can express it in this picture. For the right-sided signals, according to the definition, we can get the expression for this kind of signal. Here is example for this right-sided signal. According to the definition, we can get this result. Here, the ROC lies outside the circle of the pole radius 2. 2 is the pole of this fraction. We can express it in this picture. If n1 greater than or equal 0, the ROC of a right-sided signal is of the form magnitude of Z greater than some positive number. If n1 less than 0, its ROC is of this form. For the left-sided signals, we can determine its bilateral Z transform. According to the definition, we can get this result. Here, the magnitude of Z should be less than some positive real number. Here, the 4 is the pole of this fraction. ROC lies inside the circle of the pole radius 4. The ROC can be expressed in this picture. If n2 less than 0 or equals 0, the ROC of a left-sided signal is of this form. Magnitude of Z less than one positive number. If n2 greater than 0, its ROC is of this form. It means magnitude of Z doesn't equal 0. According to the discussion, we have now these two different signals has the same x of Z, but with different ROC. So we can know x of Z does not correspond to x of k uniquely. Only x of z plus ROC can correspond to xk uniquely. For the two-sided signals, according to the definition, we can get this bilateral Z transform. For these two-sided signals, we can get this bilateral Z transform. Here, the ROC is a ring in Z plane. The ROC can be expressed in this picture. Here is 2 is the pole of this fraction. 4 is the pole of this fraction. If the Z transform of a two-sided signal converges, the ROC is a ring in Z plane. Does any two-sided signal correspond to x of z plus ROC? For examples, for this two-sided signal, if these two conditions are satisfied, there exists the bilateral Z transform for the signal. But it's impossible to satisfy these two conditions simultaneously. For this two-sided signal, if these two conditions are satisfied, we can get its bilateral Z transform. This is possible to satisfy these two conditions simultaneously. Now we'll discuss the properties of bilateral Z transform. These properties are similar to those of unilateral Z transform. The properties are listed here. Now we'll discuss the inversion of bilateral Z transform. This is the definition for inverse bilateral Z transform. Direct inversion of the transform is complicated. We can determine it by partial fraction expansion. We have now, for the right-sided signal, we have this expression. For the left-sided signal, we have this expression. For example, according to the x of z to determine x of k, here we do not give the ROC. X of z with different ROCs corresponds to different signals. This x of z has two poles. One is 2, another is 3. According to the poles, we can have 3 different regions of convergence. In the region of convergence, it doesn't include any pole. This is the position of pole. According to the different ROC, we can get the corresponding signal. For this region, we can get this signal. The signal is right-sided signal. For this region, we can get the signal, it's a two-sided signal. For this region, we can get the signal. This is a left-sided signal. For this region, the signal is a righted signal. For this region, the signal should be a two-sided signal. For this region, the signal should be a left-sided signal. In this lecture, we have studied the definition of bilateral Z transform and the properties of bilateral Z transform and the inversion of bilateral Z transform. That's all for today. See you later.